Imagine looking out over a massive reservoir and seeing not water rippling under the sunlight, but a seemingly endless sea of 96 million black spheres, perfectly aligned, floating silently on the surface. At first it might look strange, even mysterious, almost like something out of a science fiction story. But each of these simple balls tells a powerful story about human ingenuity, resourcefulness, and the way we can confront some of the world's most pressing challenges with creativity and science. Today we're going to explore why these black balls exist, what they do, and how a solution so simple in appearance can have an enormous impact on conserving water, protecting the environment, and inspiring people to think differently about the resources we often take for granted. By the end of this journey, you'll not only understand the science behind these floating spheres, but also see how innovation, collective effort, and small, thoughtful actions can create extraordinary change. So stay with me, because what may seem like a curious anomaly on the water is in fact a remarkable lesson about the power of ideas, the beauty of simplicity, and the importance of protecting our planet. The black balls floating on the reservoir serve a very practical and important purpose: water conservation. In regions where sunlight is intense and temperatures are high, reservoirs lose a significant amount of water through evaporation every single day. When water is exposed directly to sunlight, heat causes it to turn into vapor and escape into the atmosphere, which over time can amount to millions of gallons lost. By covering the surface with black balls, the water is shielded from direct sunlight, drastically reducing evaporation. Each ball, though small on its own, contributes to forming a protective layer over the water. This simple intervention can have a huge cumulative effect when millions of balls are deployed, effectively creating a barrier that keeps precious water from disappearing into the air. This method of conservation is passive and requires no complex machinery, pumps, or energy consumption, making it an efficient and sustainable solution. Beyond just preventing water loss, these balls help maintain the temperature of the water beneath them, which can reduce thermal fluctuations that might otherwise disrupt the ecosystem in the reservoir. In areas facing drought or where water scarcity is a critical issue, such an approach ensures that communities have access to more consistent water supplies without additional strain on natural resources. It is a striking example of how a small, well-thought-out physical object can address a large-scale environmental problem, turning a straightforward idea into a highly effective conservation tool. The black balls on the reservoir play a critical role in preventing the growth of harmful algae and reducing contamination in the water. Algae thrive in sunlight, and when they multiply excessively, they can produce toxins that make water unsafe for human consumption and disrupt aquatic ecosystems. By covering the water's surface, these balls block sunlight from reaching the water, significantly slowing down algae growth. This not only keeps the water visually cleaner, but also reduces the health risks associated with algal blooms, which can release chemicals that irritate skin, eyes, and the digestive system if consumed. Additionally, sunlight can trigger chemical reactions in water, leading to the formation of compounds such as bromate, which are potentially harmful over time. The presence of black balls minimizes these reactions by limiting light penetration, helping maintain the chemical stability of the water. This protective effect reduces the need for extensive chemical treatments, lowering costs and environmental impact, and supports public health by maintaining higher water quality. Beyond health benefits, controlling algae also improves water taste and odor, making it more appealing for consumption and use in households. The black balls act as a passive, continuous shield, working day and night without requiring active monitoring or energy inputs. By combining a simple physical principle, blocking sunlight, with practical environmental management, this approach demonstrates how human ingenuity can solve complex problems in water safety and quality. It highlights the importance of preventive measures over reactive solutions in maintaining the integrity of vital resources, ensuring that water remains clean, safe, and sustainable for communities that rely on it. The black balls on reservoirs provide significant environmental and energy-related benefits that extend beyond water conservation. By reducing evaporation and limiting sunlight exposure, they help preserve vast amounts of water without requiring energy-intensive interventions like pumping, desalination, or chemical treatments. This passive method of conservation lowers the carbon footprint associated with water management, as no electricity or fuel is needed to maintain the water levels. In urban areas where water treatment plants consume considerable energy to purify and distribute water, preventing losses at the source indirectly reduces energy demand and operational costs. Moreover, fewer chemicals are required to control algae growth and chemical reactions, which further minimizes environmental impact. The black balls also contribute to the stability of the water ecosystem by regulating temperature and reducing thermal fluctuations, which can affect the life cycles of aquatic organisms. When water is exposed to intense sunlight, it heats unevenly, leading to changes in dissolved oxygen levels and potentially stressing fish and other wildlife. By shading the reservoir, the balls create a more balanced environment that supports biodiversity. On a larger scale, this approach represents a clever integration of simple materials with environmental stewardship, demonstrating how small interventions can lead to systemic benefits. The energy saved, the reduced chemical usage, and the protection of ecosystems together make this solution both sustainable and cost-effective. It exemplifies the principle that human innovation, when guided by understanding natural processes, can create solutions that are simultaneously efficient, eco-friendly, and scalable, addressing pressing resource challenges while minimizing unintended consequences. The scale of the operation, 96 million black balls, covering a reservoir, is both impressive and instructive, illustrating how small individual components can collectively create a massive impact. Each ball by itself is a simple, lightweight object, but when multiplied millions of times across the surface of the water, they form a nearly continuous layer that effectively prevents evaporation and sunlight penetration. This concept reflects a broader principle often observed in physics and engineering. Small, incremental elements working together can produce a large-scale effect that is far greater than the sum of its parts. The vast number also emphasizes the seriousness of the problem being addressed. Water scarcity is not trivial, and mitigating losses at this scale requires ambitious, well-planned interventions. Deploying 96 million balls is a logistical challenge, involving careful distribution, maintenance, and monitoring to ensure they remain evenly spread and functional. The visual impact of seeing millions of black spheres floating on a reservoir also serves to grab attention, sparking curiosity and prompting people to ask questions about why such a measure is necessary. Beyond the immediate practical benefits, the scale communicates a lesson about collective action. When many small units act in unison, the outcome can be transformational. It also highlights the importance of planning and coordination in large-scale environmental projects, showing that solving global challenges often requires both innovative ideas and meticulous execution. In essence, the sheer number of balls is a reminder that even simple solutions, when scaled appropriately, can address critical issues and inspire broader thinking about how humans interact with natural resources, creating ripple effects that extend beyond the immediate goal. The presence of millions of black balls on a reservoir also has a profound psychological and educational impact, influencing how people perceive water usage, conservation, and environmental responsibility. At first glance, seeing such an unusual sight, a seemingly endless layer of black spheres floating on water, can spark curiosity and intrigue, prompting questions about their purpose and necessity. This curiosity opens a gateway for learning and discussion, allowing individuals to understand the broader issues of water scarcity, climate challenges, and innovative solutions. By drawing public attention, the balls transform a functional intervention into an educational tool, turning everyday observation into an opportunity for awareness. People begin to recognize the value of conserving natural resources and may reflect on their own water consumption habits, inspiring more mindful behavior in daily life. Furthermore, the unusual appearance challenges conventional expectations and stimulates critical thinking, showing that environmental solutions do not always have to be hidden or purely functional. They can be visible, creative, and even thought-provoking. This psychological effect reinforces the importance of combining practicality with communication. The balls are not only performing a physical task, but also sending a message about human ingenuity and responsibility. In urban contexts, where residents may be disconnected from natural resource management, this visual intervention serves as a reminder of the fragility and importance of water. The striking imagery encourages communities to engage with environmental topics, fostering dialogue and reflection that can lead to broader cultural shifts toward sustainability. In this way, the black balls exemplify how a simple, physical solution can have layered impacts, influencing not only the water beneath them, but also the awareness and actions of the people observing them. The black balls on reservoirs also carry a symbolic significance, representing the intersection of human creativity, innovation, and necessity. While their primary purpose is practical, reducing evaporation and improving water quality, they also embody the idea that simple, thoughtfully designed solutions can address complex environmental challenges. In a world increasingly affected by climate change, population growth, and resource scarcity, these balls demonstrate how observing natural processes and applying basic scientific principles can lead to highly effective interventions. They show that innovation does not always require expensive technology or complex machinery. Sometimes a low-cost, scalable, and elegant solution can have a profound impact. The uniform black spheres, floating together across millions of square meters, also symbolize collective effort. Just as each small ball contributes to the protection of water, individual actions in society can accumulate to create significant change. This visual metaphor resonates beyond the technical benefits, inspiring curiosity, reflection, and a sense of responsibility. It highlights the power of human ingenuity to transform challenges into opportunities, encouraging a mindset that looks for creative solutions rather than seeing problems as insurmountable. The use of black balls reminds us that innovation often involves thinking differently, experimenting with simple ideas, and observing their effects at scale. It also reinforces the notion that practical solutions can be beautiful, educational, and motivational all at once, influencing both the environment and the way people perceive their role in preserving it. Through this lens, the black balls are more than a functional tool. They are a symbol of thoughtful problem-solving, collaboration, and the enduring potential of human creativity. In conclusion, the 96 million black balls on this reservoir are far more than just an unusual sight. They are a testament to human ingenuity, creativity, and our ability to solve complex problems with simple, elegant solutions. Each ball, while small on its own, contributes to conserving water, protecting it from contamination, and maintaining ecological balance, demonstrating how collective action can create monumental impact. Beyond their practical function, these spheres spark curiosity, inspire learning, and encourage a deeper awareness of our responsibility toward natural resources. They show that innovation does not always require complexity. Sometimes observing nature, applying basic principles, and thinking differently can achieve extraordinary results. As we reflect on this remarkable project, it reminds us that small actions multiplied across communities or systems can transform challenges into opportunities, shaping a sustainable and thoughtful future.